Okay, so this is a counterweight cylinder on a Grove mobile crane. The complaint was that there's a leak coming out of these proxy sensors. Now, what normally happens is there's like a rack and pinion on the inside here, or I think this could actually be, sometimes it's just a cutout on a rack, and you've got like a little lobe that switches over, which in turn will rotate your rod into the locked or unlocked position. Now, sometimes there's a seal, there is a seal that blocks off the hydraulic pressure on the inside of the cylinder from this cavity at the back that controls your locking and unlocking. Now, sometimes that seal can blow and you get oil trying to leak past these proxy sensors. So yeah, but I have chatted to the customer just based off of the fact that I can see there's damage on the rod. We're going to get the whole thing stripped. I'm going to get it in the vise now. So first things first, stuff like this that can be damaged, we want to get off before we start handling it or putting it anywhere in any vices, swinging any spanners. So I'm going to get it in the vise now and yeah, see what's going on with it. It's two nuts on here. One is just going to lock into the other just to lock them together. Come on. There we go. Move the cylinder to the bench just to get a bit better leverage. And quite a lot of oil came out of these two holes where the proxy sensors came out, so that does support the customer's statement that there is something not right inside here, because the only way you're going to get oil in the cavity where these two proxy sensors work is if there's leaking on the pistons on this rack on the inside or on that seal between the cylinder and this rear cavity, which we'll find out in a second. Let's see if we can actually get these off. 14 is a bit small, a bit too big. 13 is a bit, oh, 13 fits. Jeez. Still quite a lot of pressure inside here. At least the holding valve is working fine. So if I loosen that, the pressure being contained within the cylinder on the rod side, which is your main load holding side, that would actually go away. So let me do that. Always good to just keep a rag over there for when it inevitably does have a little bit of oil come out. Okay. Okay, so how this works is try not to get too confused by all these ports. This port and this port, that's just for your rack and pinion to rotate the cylinder and the rod in the front. So ignore these for now. What you're going to have here is two ports. This one's marked as E, but this is basically like your B line. And this is ARV. This is just for like almost like a manual override for if there's issues with the crane, you can still fold up the cylinder and retract it if you need to. So these are your main working lines here on top to move this cylinder in and out. So this valve over here is going to hold pressure on E, which is going to the front of your cylinder to bring the rod in. So because the cylinder lifts a heavy load and brings it up and holds it, you're going to need a holding valve so that when you are done putting oil in here to bring the cylinder into where you want it to be, this valve will shut and it will hold the oil and contain it on the inside of the cylinder on the rod side to keep the cylinder where it's supposed to be. They don't really need one for out because you're not really holding a load pushing out, you're just going to slowly drop the load. This will have what's called an internal pilot. So if you want to now extend the cylinder out and drop a weight, the oil that's being contained in the front and being kept in there by this valve needs to be opened. So it's going to be opened via what is called an internal pilot. So this port is going to send oil to the back of the cylinder to push it out, as well as into another little cavity onto the side of this to open the valve so that the oil that was being held by this valve can now come back out this port and go back to tank. So these proxy sensors are going to essentially do the same job as the two that were over here. They are going to just pick up on the shaft so that it can tell the crane's computer where it is in its stroke. So you can imagine somebody sitting in the cabin, they can't see what's going on here, they can't see the counterweight at the back of the crane. These are going to start giving them information inside the cabin so that they can see, right, is this pushed all the way out? Is it brought all the way in? So is the counterweight all the way up? Yes, no. These two are then going to be able to tell the operator in the cabin, is the counterweight locked or unlocked? So all these are for is to tell the computer where certain components are in their range of operation so that they can get the information they need. Right, now that everything's off, we're pretty much safe to do whatever we want now. Holding valve is out, so there's no pressure contained with inside the cylinder anymore. So we are going to just mark this gland nut and get all these Allen caps loose and see what's going on inside. good idea to just cover everything. A little bit of oil shot out of here now while I tried stripping it. Just cover all the ports, front and back, while trying to slowly pull it out, so you don't have oil doing that. Another option is just to orientate the cylinder in such a way, if you're not in a rush, orientate it in such a way that the oil can drain out over time. Give it 10-15 minutes, just so that when you are trying to pull this rod out, it's not going to make too much of a mess. Okay, since it's so free moving, you can feel everything's nice and loose, I'm rather just going to use the weight of the rod itself to kind of just tap the gland nut out. There we go. Get that out the way. Just give it a little bit of a wipe. Okay, barrel looks good, no major scratches or anything. A little bit of dirt, but nothing crazy. This is that rod that runs on the inside of your chrome shaft. Let me just turn this around. So it works on the inside of that square spline, if you want to call it that, which is locked in place, and it will rotate this entire rod inside the barrel assembly, so that the front of the rod here can lock and unlock into one of the counterweights. I think what I'm going to do first is get the piston and the gland nut off the rod, get that out of there, so that we can start running through all of these components, and then we will attack the back section here. Okay, first thing you want to look for is if there's any sort of method that they've affixed this piston to the rod that we might not be able to see. First thing I would like to see if there's any grub screws or pins underneath here, which there are not. Don't really see anything on the face here. So I'm going to just get all of this. Looks like this could actually be the locking mechanism for the piston, not for this inner section. So they've got a little half moon pin here, circle up with a washer underneath. I'm going to get that out. Surely that's how we are going to get this loose. Let's give this a whirl. Oh, that's a bit tight. Let me just go put this where it belongs. There we go. That's not a good sound. Ooh. Forgot to hit the record button again, but came off pretty easy. Didn't put too much of a fight. It's a good thing we did go ahead and strip the entire thing. You can see the gland seals are starting to extrude. Rod is a bit worse for wear, so we will go ahead and have that hard chromed. Now to attack the back section here a little bit. Okay, no, it looks like it is the rack and pinion design like I initially thought. We'll get a better look once we get these two pieces off. You can see there's a little brass bush on the inside of here, which runs on the front of this little rod here, just so that this doesn't run directly on steel on the inside here and wear out. So these are essentially little miniature barrels on the inside. You'll see now when I get this rack out, get that out now, there will be seals on the end, each acting as their own piston, which runs on the inner lining of these two end caps. There you go. So you can see the seals are a bit worse for wear. This one's a bit better on this side, but this is probably where they might have been getting a bit of an issue. Oil would have pressurized inside here to try and push this over. Oil would have leaked past this seal, filled up this cavity, and started leaking out of the two holes on this side where the proxy sensors screw in. Now we should be able to knock out this main rod with the pinion gear on it. I'm just going to move this further back. There we go. So you'll see teeth there, teeth on there. They mesh together like so, and this piston will move over and start rotating this rod as a full rack and pinion setup to rotate this rod, which in turn, like I said earlier, this goes inside your main chrome shaft, and that will rotate it into the lock and unlock position. Now there is a seal on the inside there, a white PTFE seal, which seals this surface here, and it looks a bit flat on the inside, so I suspect that is actually our primary issue. So I'm going to get that out, and yeah, I think we have found our problem. Looks like it's a single acting PTFE seal with an energizer O-ring, which isn't necessarily incorrect, but for longevity's sake I would still prefer to use, or prefer using a U-cup seal. So I'm going to change that out to a different seal arrangement. Okay, just going to put this into the side for now. So the gland nut seems to be running on, this is your wiper seal. This will prevent dirt and muck, as you can see here, getting inside of your cylinder. This is your primary U seal or U cup seal. So you can see it's started to extrude over time. Now what happens with extrusion is this is a steel gland nut, so you can't have this steel touching chrome on your chrome rod, or it'll start scratching the chrome off your shaft. So they normally leave it with about a 0.6 millimeter clearance, and your rod is actually running along these 3 wear strips, which are going to be close to hardware size and acts as your bushing on your rod. So there is a 0.25, maybe 0.3 gap between this steel here and your U-seal, or between your rod and your gland nut. So your U-seal can start to, over time, extrude through that 0.3, 0.25 gap, especially after multiple heat cycles, pressure cycles, and depends what pressure the system is running at as well, what type of duty cycles it's working, etc., etc. So you have your U-seal, then you've got a single acting rod copper, which couples with an O-ring. Let me get that out. Just be careful not to scratch the steel of the gland nut. When you put your new seals in, you don't want any scratches from your pick on the inside of your gland nut. So this normally sits like this. It is a single acting seal, same as the U-cup seal. You've got a cup on this side. Oil comes in, pushes this inner lip this way into your rod, and this outer lip this way onto the steel on the inside of your gland nut here, preventing oil from getting around either side. How a single acting rod copper works, you do get buffer seals in the same size, which are similar to a U-seal. They act as a bit of a surge breaker, because you can imagine pressure's coming from here inside your system, wanting to push oil through the gland nut and out this way. So your seals are being energized from that direction, the cup side, and on a rod copper you've got a little groove here. This is your pressure side. Oil will energize this O-ring and press this rod copper into the rod with quite high amounts of force. Also acting as a seal, but it's not going to be as positive of a seal as a U-seal. So it will seal, but you will find over time, if you're just running on a copper seal, you will have a little bit of sweating over time. Yeah, but when it comes to damage on your rod, it's a lot better to have a copper running in conjunction with a U-seal, because these tend to handle damage on your chrome rod a lot better than a U-seal. Yeah, let's get the rest out. These look like they'll be 9.5 wide by 2.5 cross-section hard wear strips. So this is a resin-infused fabric weave. These can handle an incredibly high amount of load. So like I explained, this is what your rod is actually going to be running on as a bush to prevent the chrome rod from actually touching any of these steel steps along the inside of your gland nut. If this was a cast iron gland nut or aluminium or phosphor bronze, you could run your rod directly on the material because it's a lot softer than steel. Now this O-ring on the outside seals the outside of this gland nut to the inside of the barrel where it locates. So it's a lot simpler than what you've got going on the inside. This is a static environment, so O-rings are typically better used in a static setup. If you've got a dynamic setup, i.e. your rod dynamic, moving in and out, you're going to want to use different types of seals. O-rings tend to roll in a dynamic application. Unless you use a 90 shore O-ring, then I guess you could get away with it, but it's a little bit more primitive. There's a lot better designs for that application. Now this is a PTFE backup, so your O-ring was sitting there. Now the reason they use this is there'll be a 0.1 clearance on this gland nut as opposed to the diameter of the inside of the barrel, so that it's not size for size, so that this can slide inside the barrel. Now the reason they use it is you can eventually, like on the U-seal, have your O-ring start to extrude through this gap, and sometimes you can get rust, like you're going to see here. Starts to get a bit rough on these edges on the inside here where your O-ring could be sitting up against. So a PTFE backup or a rubber backup just protects your O-ring and gives a nice, it's a lot more malleable of a material, so it'll start to conform to whatever groove it's in. So it'll create a nice flat smooth surface for your O-ring to energize on. Sometimes steel can also get quite rough, so you can imagine this O-ring energizing, de-energizing multiple times in this direction. A steel surface can end up being quite abrasive, so this also is just a lot smoother of a surface to protect your O-ring over multiple energizing cycles. Now for the piston, you'll see runs on a copper seal, similar to the two-piece copper on the inside of the gland nut. There will be an O-ring underneath here that energizes and presses this copper into the barrel wall. There was a brass wear ring that's set in here. Now you could use that same resin infused fabric weave. This is just how they do it from the factory. It can handle quite a lot more load. I wouldn't say quite a lot more, but a decent amount more load than the these blue wear strips. So, but yeah, you can use the resin infused fabric wear rings in this application, but if there's no damage to these, which actually there is quite a lot of scratches on here, just over time a little bit of particulate gets in the oil and starts to scratch this up, so I will replace it with a wear strip. And yeah, this again, O-ring backup, same setup as on the outside of the gland nut, PTFE backup in there. This is the correct orientation. You can imagine the cylinder is always in more pressurized in the retract position because it's trying to lift a counterweight, so most of your pressure is always on your rod side, wanting to escape this way around the seal, so, and out the back. So it's good that you have your O-ring and backup in this configuration, because your backup is on the correct side. I have sometimes seen people where they accidentally will have the backup then on that side. Let me just wipe it there so you can see better, which is technically incorrect.